on the shaft and putting a brace that won't bend.
This is the pressure cutoff valve. So when the compressor reaches 120 psi, this closes the circuit and will tell the compressor to shut off. So we're just testing to make sure it's calibrated to the right. So it's 120, not like 130 or something. So everyone's hooking up the compressor directly up to here so we can get a reading.
So the ball, where's the actual robot? Is basically replace the circle over there. Or it could be used for the circle, right? Mark?
What?
Yeah, alright.
Yes. What he said.
Yeah, so this will replace the circle. So when the ball rolls in, it'll roll over, tip this over, and then it'll stop being shot by the puncher thing.
So what is this?
This is El Toro. We got new motors here, and we also put on a hinge here, so this way we can attach the motor so we can adjust the angle of it.
Let me get the ball.
So what is this?
So Matt gave us new shooter plates. They're made out of stainless steel now.
This
what's the other one?
This is 11 gauge stainless steel. So we went from 090 aluminum to 11 gauge stainless steel. So it's pretty much not bendable at all. And it's also, and you're gonna tell, it's a lot wider. This is the old base. And this is the new base. This is a 4-inch radius of the bones, and this is 2-inch I think.
So what's the problem with
Okay,
this?
so we've got this awesome 3-stage scooter that is awesome at 3 stages. The first stage is very simple. It's the first stage, these things don't move. So a hose attaches here, and this is not moving. So you attach a hose there, it's fine. Second stage isn't that bad because the second stage is only moving from where it is here, to up here. So we can just put a hose here that moves from down here up to here, that's no problem. But the third stage up here is moving 16 inches from where it's starting to where it's ending. And we can't mount it on the side like these guys because it won't fit through this hole. So we're thinking of mounting the bottom. So the hose has to go, but then the hose has to pass through all of these holes. So when this extended, the hose would have to go in this hole here, and then through this hole again here. And there's no really way to get the hose to feed through here because this extends faster than your camera will catch it. If the hose is rubbing against this edge, it's just gonna rip the hose apart. So what we're gonna do is we're gonna try to find a cylinder that has both of the extend and the retract sides, both mounted up top, one on the side, one on the side, so that the hose will just attach to here, and then it will just lift up with here. All right, 3, 2, 1.
Hold. 3, 2, 1.
Oh.
1. Fire again. 2 is.
We're gonna break the table yet? Wait, seriously.
2, 1. 2, 1.
Yeah, that's a lot. That's still.
That's turbo.
What, 40. 3, 2, 1.
What are you doing?
I am testing and repairing pneumatic leaks. So we've got all these fittings hooked up together. This is just brass fittings, so air is obviously leaked through here. So we use this stuff, where is it? Called Teflon. It's very thin tape that we wrap around the fittings, around the threads. So when the fittings are attached, it seals it.
and the air can't get through. So then I'll test it, I'll pressurize it up, and then if I put a little bit of water with some soap on it, if there's a leak, there's gonna be a bubble that shows up. It's very obvious, so that's what I'm working on.
We attached a Talon, which is basically the same thing as a Victor, to test it out.
Just a
like,
different controller, but
yeah.
and it's acting a little bit slower than it normally does.
Trying to
Than the
find
other
the
Victors
problem.
are, so we're trying to find the problem for them. Soldering.
Yeah.
A sensor. It's pretty slick.
This is the ultrasonic sensor. We're trying to solder 3 wires into it. Well, this is a power distribution board, and he's mounting like a support bar that this is gonna rest.
So we're putting like all the stuff inside the robot right now?
Yes.
This is in final, or is it final?
Well, we're just like mounting stuff on, and then if it doesn't work out, we'll just change it.
Electrical board.
This is the power distribution board. This is the battery, and this is the serial.
What are you doing?
I'm going to start messing with the new idea we had for an opposite direction feed system, where you were involved in this. You can turn a fake camera on yourself if you want. Give yourself credit, Matt, for feeding the ball instead from the opposite direction and shooting the same direction we intake, for feeding the ball over our shooter and dropping it in, so everything is linear and just goes in one direction.
Is this like the simulation of how the robot geometry will work?
It's a very, very early thought. I'll leave it at that.
I'm CADing the pneumatic system, where you can see on my handy-dandy tablet device.
What are you doing, Steven?
I'm still creating the field barrier.
So these are like the support things?
Yeah, for the 2x4.
Steven, what you doing?
I'm screwing some cardboard into this plywood so we can turn the goal hotter. We are making. I'm just marking up the pool noodles and cutting them up so we can start creating.
Tape? Alright. This is a one-handed job, or do I need 2 hands?
You might want 2 hands.
I've got a plan, don't worry.
Set on the pool noodles.
And and there. All right, just stay right there.
Hi guys.
So what am I doing?
Just wrap it around.
So what you got? Why were you all dressed up, Steven? What were you guys doing?
We got money.
No, we just came from a meeting with Stanley, and they gave us a sponsorship of $500, and now we're planning to invite them to our warehouse, possibly Friday or Saturday, in order for them to become a long-term sponsor.
What are you doing? Chairman's?
We're brainstorming for what we want to put in the chairman's essay. Got some nice ideas.
We're planning on doing some sort of survey of team members we're still trying to figure out the questions. We're going to survey team members.
We are working on the chairman's essay. At this point, it's a lot of ideas being thrown around, and we're actually going into starting to write it, and we're coming up with first sentences, each of us. We have
So
words.
pretty much, yeah, we have characters. Look at all the characters, man. Okay, so pretty much what we have is right now we've set a theme by quoting Hillary Clinton. So yeah, so something, you know, dynamism is a function of change.
What is the code supposed to do? It's supposed to make the robot drive. And technically, you see the big red light there on the thing?
Yes.
If we get closer than 5 feet to the wall, or rather within 5 feet of the wall, the lights is supposed to go on. So, I'm really out of energy. God, okay.
Did you capture me in there?
Yes.
You're supposed to be
and you making like a smiley face.
I'm trying to get the thing to drive. It's not driving.
What's the problem?
That's a good question.
We don't know. We're trying.
Alright, so today we are starting off by measuring the disparity between the encoder.
What does disparity mean?
Difference. The difference between the actual and the real distance from the robot to the wall.
One of the cables that connected the power to this digital sidecar on the robot was not plugged in correctly, so Anisha and I got that open this morning and we found it out and we plugged it back in and now it works. Because everything is actually connected.
What are you working on, Danielle?
Contacting those cyber rams about Dream First and talking about Woody Flowers with my man Brandon over here.
What's Woody Flowers?
Woody Flowers is this award that's given to a mentor on the team that students feel really exemplifies what First is and really nurtures the children on the team.